Have you ever asked an AI for some code and gotten back like 1,000 lines when you know 100 would have been perfect? Yeah, me too. Today, we're going to break down this awesome framework, inspired by the one and only Karpathy, that'll teach you how to get these models to write the clean, simple code you were actually hoping for. I mean, seriously, does this quote just hit you right where you live? It's that classic moment you ask for a simple little feature, and what you get back is this mountain of bloated, over-engineered code. It's probably the biggest headache when using AI for coding, right? But here's the kicker. What if the problem isn't really the AI? What if it's actually us and the way we're asking?
Look, if you're not in your head right now, you are definitely not alone. But the good news is you don't have to just live with this. There is a much smarter way to work with these AIs to get the kind of code you'd actually be proud to ship.
All right, so before we jump into the solution, let's play detective for a minute. We need to figure out what's really going on. Why do these super powerful models so often spit out code that's, well, a complicated, wrong, or just plain weird mess? So here's the thing. It's not that the AI can't code. Oh, it can code. The real problem is that it has absolutely no internal critic. It just makes an assumption based on all the code it's ever seen, and then it's off to the races. It just plows ahead without ever hitting the brakes to ask, hey, wait a second, is this actually what you wanted? And that, my friends, brings us to the solution. It's a simple, elegant framework built on just 4 principles. And listen, this isn't about some crazy, complicated prompt engineering voodoo. Nope, these are just clear, straightforward rules of the road that are specifically designed to fix the AI's bad habits and get it to think a little more before it types. So let's get into it. It all boils down to just 4 core ideas. And I'm telling you, these 4 rules are going to completely change the way you work with your AI coder. Okay, here's the whole game plan on one slide. First up, think before coding. That's how we stop it from making stuff up. Then we've got simplicity first to fight that crazy code bloat. Surgical changes is all about stopping the AI from messing with code it shouldn't be touching. And finally, goal-driven execution, which is all about giving it a clear finish line to run towards. Let's dive into each one. Okay, principle number 1, think first. This is a big one. It's basically about forcing the AI to show its work, to do all of its thinking right there in front of you before it even dreams of writing a single line of code. We want no more secret assumptions, no more blindly running down the wrong rabbit hole. So what does that actually look like? Well, it means you tell the AI straight up, state your assumptions. If my request is fuzzy, give me a few ways you can interpret it. And hey, if you think there's a better way, push back, tell me. And maybe the most important part, if it gets confused, it has to stop and ask for clarification. Simple as that. All right, next we've got a 2-for-1. Principles 2 and 3 really go together, and they're all about one thing: keeping your code simple and your edits sharp. This is the direct medicine for that 1,000-line monstrosity we talked about at the beginning. Principle 2, simplicity first, is a hard rule. You want absolute minimalism. You tell the model, write the minimum amount of code to solve this problem, period. No speculative features, no fancy abstractions you don't need, and definitely no extra flexibility that I didn't ask for. We're aiming for elegance here. And that brings us right to principle 3, surgical changes. Think about it this way. You want a surgeon with a scalpel, not a construction worker with a sledgehammer. The AI's job is to touch only the code it absolutely must. It doesn't get to reformat things on a whim or improve code next door. Just precise, focused edits. Okay, now for what I think might be the real game changer here. Principle 4. This last one completely flips the script. You stop being a boss who gives vague orders, and you start being a coach who defines exactly what a win looks like. Then you just let the AI figure out how to score. And this comparison just nails it, right? Instead of saying something vague like, hey, add validation, you change it to a concrete goal. First, write some tests for bad inputs. Then, make those tests pass. Instead of fix the bug, it becomes write a test that makes the bug happen and then fix the code so the test passes. See the difference? You're giving it a target it can actually hit and a way to know it got it right. Okay, so this all sounds great in theory, but how do you actually do it? Well, the best part is this isn't just some abstract idea. You can start using this whole framework like right now. And the person who put this guide together made it incredibly simple to get going. Seriously, it's this easy. Pop open your terminal, navigate to your project folder, and just run that little curl command you see on the screen.
It'll download a simple file that has all these rules written down. From then on, you just give that file to your AI every time you ask it for something. It's like giving it a cheat sheet for being a great developer.
So how do you know it's actually working? Oh, you'll know. You'll see it in your pull requests. The code changes, your diffs, will be tiny and focused. You'll stop spending half your day telling the AI to rewrite its own complicated mess. And you'll start getting those clarifying questions before it goes off and wastes a bunch of time. The end result, just clean, minimal PRs that are a dream to review. And this quote right here really just sums it all up, doesn't it? Don't tell it what to do, give it success criteria, and watch it go. These AIs are amazing at chipping away at a problem until they solve it. Your job isn't to be a micromanager anymore, telling it every little step. It's to be a great project manager who clearly defines what done means and then gets out of the way. Which really leaves us with a pretty mind-bending thought to wrap up, right? When we start working this way, are we even programming in the old sense of the word, or are we stepping into a totally new role, where our main job is to be a teacher, teaching these incredibly powerful tools how to reason, how to ask it questions, and ultimately, how to think more like a seasoned developer? It's a huge shift. Anyway, something to think about. Thanks so much